The origins of oxygen in Earth's atmosphere is derived from life. Ancient microbes first produced oxygen through photosynthesis. Initially, scientists believed that the origin of oxygen on Earth began with photosynthesis of microbes called cyanobacteria. However, a new study showed that photosynthesis originated a billion years earlier than previously thought, which means oxygen was available for living organisms close to the origin of life on Earth. Researchers studied the molecular machines responsible for photosynthesis and found that photosynthesis may have occurred more than 3.4 billion years ago. This is long before oxygen or cyanobacteria were thought to have existed on Earth. This means there must have been predecessors, such as ancient bacteria, that have evolved to carry out photosynthesis and produced oxygen. Even though tiny microbes were producing the gas as a byproduct of photosynthesis, Earth's early atmosphere and oceans were devoid of free oxygen. Free oxygen does not combine with other elements such as carbon or nitrogen. Much of the oxygen produced reacted with iron, sulfur and other chemicals in the oceans and in the rocks on Earth's surface. As a result, oxygen entered into seafloor sediments and eventually into Earth's interior. About 2.4 billion years ago, oxygen in the atmosphere suddenly increased by about 10,000 times in just 200 million years. This period is known as the Great Oxidation Event, which changed chemical reaction on the surface of the Earth completely. At the same time, when free oxygen started to accumulate in the oceans, changes occurred in the composition of Earth's crust. Before oxygenation, rocks on the Earth contained a mineral called olivine. Researchers showed that when olivine comes into contact with water, it initiates chemical reaction that consumes oxygen and locks it up. However, as the continental crust evolved to composition more like today's olivine virtually disappeared from Earth's crust. Without that mineral to react with water and consume oxygen, the gases was finally allowed to accumulate. Oceans eventually became saturated and oxygen crossed into the atmosphere.